Hang on, I gotta reset. Okay, sorry about that. I had some scribbles that I didn't need on there, and here is what we're talking about today. Once upon a time, I would have done this as curve sketching in Unit 3. It's not necessarily Unit 3 anymore, but we are certainly covering local maxima and minima, which is plural for maximum and minimum, and also increasing values. So what I did was I just randomly picked the W graph, so a degree 4 curve from advanced functions, and I've pointed out some spots that are important. So here's your curve, X and Y axis labeled. This is considered a local minimum. And the reason it is a local minimum is because there are points that are lower than that. So it's just the bottom of a valley, but not the bottom of the lowest valley. This is the bottom of the lowest valley. So this is called the absolute minimum. So you don't get any more minimum than this, so it's called absolute. I have labeled this one A and I've labeled this one C, just for reference. Because this picture goes on forever upward, that means this isn't an absolute maximum, it's a local maximum. And I've labeled it B for reference. Then I've tried to dig out some colored pens and stuff like that to explain the difference between increasing and decreasing. So if you take a look at this picture, this is going downhill. And that means from negative infinity till you get to point A, that is where this function is decreasing. It is also decreasing from B to C. And I've said that here. Improperly, but still you get my point, I hope. Increasing from A to B, so you're going uphill in that section, and also increasing from C all the way to the right, so that is positive infinity. Things that might help you in this particular unit are some facts that you hopefully remember. There, that's how that stuff happens. That you hopefully remember from advanced functions. So I'm just going to do a little doodling here for you. I kind of hope that you remember that this is a positive degree 2 and this is a negative degree 2. I hope that you remember that this is a positive degree 3 and this is a negative degree 3. I hope that you remember that what I drew was a positive degree 4, all with y equals in front of it, and this is a negative degree 4. So those are some handy things to know. You should also hopefully remember that if you've got the x-axis, poor diagram, that when your curve bounces off it from above or bounces off it from below, that is what you call a double root. Now we have actual names for them. They're maximums and minimums that just happen to happen on the x-axis. And same kind of deal, if they squiggle their way through the x-axis, this is what you call points of inflection. Now what happens in calculus is these no longer have to stay on the x-axis. That'll happen in the next note. So we're going to find, in this note, we're going to find where the local maxima and where the local minimum are. Some of them will end up, being absolute maximum or absolute minimum. And we're also going to find where the increasing and decreasing values happen. So I have a question. It's here. And the question says, given the equation y equals x cubed plus 3x squared plus 1, determine the maximum points, so one or the other, or not both. You can't have both at the same time. These are my steps, and find the increasing and decreasing intervals. These are my steps, and then sketch. So You can pause at any time and decide for yourself how much time it takes to write this stuff down. But we have to follow these steps for max min. I'm going to keep going. So the first step is to take the derivative. Go figure that you're in calculus and you have to take the derivative. The next thing you have to do is you have to set the derivative equal to 0. Those are the two easy-ish things. The reason I say that is because step 3 is to solve for x. And solving for x leads you back to the first unit of advanced functions, and that is if you've got linear equations, like grade 9 questions, you'll probably overthink them, in which case you need to kind of step back, which is why you need to practice these things. Quadratic equations, you'll need to solve them like in grade 10 or 11. It is also possible that I ask you to do long or synthetic division, and when you were in advanced functions, I said if you were going to calculus, you needed to learn long division instead of synthetic division. Now is payback time if you didn't actually listen to that. So I'm going to go through my steps. So the first thing I'm going to do, because I tend to make silly mistakes, is I'm going to write the original equation down at the very top here so I don't have to scroll back and forth. Then I'm going to start doing these steps to finding the max min. So I'm going to dig out my blue pen just for a change of color, and I'm going to take the derivative. So that's drop the 3, keep writing, make it 1 less, plus drop the 2 onto the 3, multiply, make it 1 less, the derivative of a constant is 0. And then I'm going to take the derivative and I'm going to make it equal to 0. So that means 3x squared plus 6x, which is a much more easier way to write that, is equal to 0. Now, I can common factor. So this is the tough business because do you remember all your types of factoring? Just like advanced functions, I'm going to take each of those parts and I'm going to make them equal to 0. In this case, I have to divide both sides by 3, and I will end up with an x value, not an x-intercept, just a random x value of 0, and another random x value of -2. And I say random, it's random to you, it's not random to the question. So now I need to follow step 4, which is actually also fairly difficult. And the reason I say that is because it says take these x values, which I'm going to turn to blue because I messed my color coordination up, and it says sub them back into the original. That means I have to sub these back into this black statement because that is the original. I am trying to find an x and a y. I've got my x's, I need the y. Therefore, I sub it into the y, not the y prime. So, I think I can fit this in here. I'm going to call it f at x instead. So I'm about to find f at 0. So 0 cubed plus 3 times 0 squared plus 1. So that 0 plus 0 plus 1 is 1. So I know I have either a maximum or a minimum sitting at 0, 1. I have to do the exact same thing for -2. And pretending that I'm going to a school that doesn't let you use a calculator, I'm going to try to do as much of this by hand. So -2 cubed is -8. -2 squared is 4 times 3. That's 4 plus 1 is 5. So I have another point at -2, 5. And to sort of get this out of the way, I'm going to put these things on the picture graph. So 0, 0 is not one of the points. One of the points is 0, 1. So I'm going to ballpark it there. This is just like advanced functions, meaning it's a sketch. So you got to label everything. And -2, 5 is like, let's put it there. And before I forget, I'm going to label the x and y axis. So I have done sort of the first part of this question, determine the maximum and minimum points. I can kind of guess if these are maximums or minimums, but part of what you have to do next is also find the increasing and decreasing intervals. Now, there's something to be said about this, and it takes me back to what I was babbling about compared to advanced functions on this slide, and that is, for our equation, it is a positive x cubed. That means I should be expecting this shape. So if I don't end up with that shape, something's gone wrong. So let's check our increasing and decreasing. Here's the instructions. Instruction 1, draw a number line. I've already set that up. 2, put all the maximum, minimum x values on the number line. So that means I have to take x equals 0 and x equals -2, and I have to place them on this number line in the correct order. So I'm going to put -2 here, and I'm going to put 0 there. Then it says test the x values in and around those on the line. So I need to test x values out here, in between those two, and out here. And I have to test them into the first derivative. So the name of this is also called the first derivative test, because you are testing into the first derivative. Go figure. When you get your result, positive answers mean that you're increasing, negative answers means that you're decreasing, and if you get a 0 answer, it means that you messed up somewhere. So I have to make sure that I don't pick -2, and I don't pick 0 to put in the first derivative. So I need to go back up here, and I need to steal the first derivative. So here it was here, but then I cleaned it up, and I have this one. Oh, I hate it when that happens. What the heck? There we go. So I'm going to change that 0 to a y prime because that's what it was. I need to keep it labeled. I'm just being lazy with my dragging approach. And I need to label this appropriately, meaning this isn't y, it's y prime, because it's the first derivative. I could also call it f prime at x, which I'm going to start to do right now, because I am going to take f prime at x, and I'm going to put in -3. So I need a number that is to the left of -2. I can pick -47 if I want to, but I'm going to pick -3. So here's me putting -3 into the first derivative. And then I'm going to do some math. So -3 squared is 9 times 3 is 27. Minus 18 is 9. That's positive. So it's increasing. So in this space, we're increasing. I'm going to get rid of that arrow. Now I'm going to find a number between -2 and 0. So I could pick -1.573. But I'm not going to. I'm going to pick -1. And again, I'm going to put that into the derivative. So -1 squared is 1 times 3, minus 6 is -3, and that's decreasing. And then finally, I need to pick a number outside of 0, so I can pick anything I want. I am choosing to pick 1, and I'm putting that into the derivative. And this just happens to be the same value as down here, which is a coincidence. What I care about is that it's positive, which means I can say increasing. So what I have to do is I have to make sure that my picture matches my test. So I have to increase until I hit x equals -2. Then I have to decrease from -2 to 0. Then I have to increase again from 0 till the end. So increase, decrease, increase between these points. So increase, decrease, but don't go any lower than this, increase again. That's bad, but I'm not going to redo it because I'm on a smart board or actually a tablet. And we get that picture. And let's double check. Oh my gosh, it's the same kind of thing that we'd be getting in advanced functions because math fits together. Okay, so there's one last thing I want to show you before we move on to another question, and that is sometimes I am going to ask you, or a book is going to ask you, or your future math class is going to ask you for increasing values. So if a value is increasing, or if it asks you for increasing, you get to say things like, it's increasing on the x's from -infinity up to, but not including -2. -2, there is no increase or decrease. That's your maximum or minimum. Then we have 0 to +infinity, which is out here. You can then say decreasing, again with the x's, and it's from -2 to 0, not including either one of them because those are your maximums. So if you can discover that increase, decrease, increase, what that means, you can then maybe hint to yourself that this one should be a max. Haven't determined if it's local or if it's absolute, but this is a min. And then you can check your picture. Yes, that is a max. Yes, this is a min. They are both local, not absolute. So I'm going to take a little hand cramp break, and I will be back at you with this question, which has a little bit of extra stuff. So given the equation, y equals x to the 4th plus 4x to the 3, determine the maximum minimum points, determine the increasing and decreasing values, just like before. But here's the back to advanced functions information, and that is we also have to find x and y intercepts. So I'll be reminding you about that kind of stuff after my hand cramp. Okay, you get to start questions wherever you want, meaning you can start with max mins. You can't start with increasing and decreasing because you need this information. Or we can start at the beginning, and it really doesn't matter as long as you do all of it. So I'm going to start with the x and y intercepts so that we're reviewing some of the advanced functions stuff. So x and y intercepts do not require any derivative stuff at all. So I'm going to do what we did in advanced functions, and I'm going to start doing this from now on, and that is to label what I'm doing. So x-intercept, just like the olden days, let y equal 0. So 0 equals x to the 4th plus 4x to the 3. And I am going to common factor that because I can. So that's x to the 3, and then leave an x behind and a plus 4. And then just to annoy you, dig out the green pen. X cubed is equal to 0. X plus 4 is equal to 0. So if I take the cube root of 0, I don't have to worry about plus minuses. But I end up with an x-intercept of 0 and another x-intercept of -4. And the thing is, I hope you kind of remember that when you're doing x-intercepts, you have just found a point of inflection because this came from an x cubed. That doesn't happen in maximum minimum. That happens in x-intercepts only. So now I'm going to dig out my blue pen and find the y-intercept, singular. So that's f at 0 is equal to 0 to the 4 plus 4, 0 to the 3 is equal to 0 plus 0, which is 0. And this is my y-intercept, which should make sense because if you have an x-intercept of 0, you always have a y-intercept of 0. So I am going to take this grid down below a little bit further because sitting there doesn't make it helpful whatsoever. So group it together and I can drag it wherever I need to. Something else I'm going to drag wherever I need to, oh, that's separated, is I need the original equation because I have to keep referring back to it. So I'm going to write it here and make it draggable. And now we get to start the new stuff. We get to start the maximum and minimum points and then move on to the increasing and decreasing. So I think I can fit maximum minimum points in here. I'm going to keep going with blue, and I'm labeling what I'm supposed to be doing. So my teacher isn't guessing. So maximum minimum mean I have to take the derivative. So that's 4x to the 3 plus 12x to the 2. And I have to set that equal to 0 according to my rules. And I might as well not set that equal to 0 and recopy. I'm going to set it equal to 0 and factor because I can. So x plus 3, green pen, 4x squared equals 0, x plus 3 equals 0. I'll have to move my grid again. Divide by 4, x squared equals 0. X is equal to plus or minus the square root of 0, which is meaningless in this question. And we end up with a maximum or minimum of 0 from here and negative 3 from here. Now the thing is, you might look at this and say, ooh, double root. But double roots don't happen for max mins. They happen when you're doing x-intercepts. So you've got to keep your facts straight. While I'm up here, I'm going to take this thing and drag it down because I'm at a point where I need to find the y values for these x values. So, back to my black pen because I'm dealing with this. If I put 0 into the original to find the y, hopefully you realize I've already done this. That's 0. So we have a maximum or minimum of 0, 0. So this point of inflection is a 0, 0. Next up, putting negative 3 into the original. So that's positive 81. That's negative 27 times 4, which is negative 108. And that's negative 27. So we have another max min, not sure which, of that. I need to take another little hand cramp break, and I'll be back to do the first derivative test so we can figure out what these things are. Sometimes I just need a little stretch. All right, so if you want to, and you can do this at any time, you can take all the points that you've found so far and put them on the grid and then do the first derivative test to find your increasing and decreasing intervals. So I'm going to do that now only because my page is getting a little bit long. So I know I have an x-intercept slash y-intercept at 0, 0, and I also know I have an x-intercept at negative 4. So I am going to put those dots on this picture and hope that my picture is in the right spot. So I have a 0, 0, and I have a negative 4. And these are nothing special until I realize that, oh, this one is either a max or a min, and then I also have a negative 3, negative 27 on this picture. And something I should really do is label the x and y axis. So now I'm all set to go for my first derivative test, which I am going to do down here. So that's how I label my first derivative test. So what you're supposed to do is you're supposed to draw a number line. Remember this part? Check your steps if you need to. And on the number line, you're supposed to put the x values that you found up above. So that is the 0 and the -3 that I found when I was finding the max mins. So the 0 and the -3 x values. And then I can put on the green arrows if I want. I don't feel like it this time. I need to find a value out here. I need to find a value out here. I need to find a value out here. And I need to sub them into the first derivative. So I need to sub them into 4x cubed plus 12x squared, or 4x squared times x plus 3. Oh, did not mean to do that. Yay, they're attached. Now, what I got lazy doing was I didn't write down the y prime equals to say that this is the first derivative. Now, some of you are going to guess why I wrote it twice in two different ways. I'll show you in a second. So, in the previous example, what I did was I stuffed it back into the original equation. Sorry, the first derivative original. So, for me, that's f prime is equal to, or f prime at -4. So that means 4 times -4 cubed plus 12 times -4 squared. And if you're at a school that doesn't let you use a calculator, that's pretty tough stuff. I'm going to dig out my calculator because these are big numbers. So I'm going to do 4 to the exponent 3, and I know it's negative, times 4 is equal to, so that's negative times a positive, that's -256. Plus, and then the other thing is 4 times 4, so 16 times 12, and that's plus 192. So I've got 192, and I'm going to minus off that 256 because it's negative, and I end up with -64, and -64 is, go figure, negative, so it's decreasing. So now I'm going to show you why I wrote down the second one. And if you looked over any of the polynomial inequality stuff, or if you looked over any of the rational inequality stuff, that is where we covered the shortcut. So I'm about to show you the shortcut. I'm going to pick a number that is lodged firmly between -3 and 0. So I'm not going to pick -2, because that's a pretty big number. I'm going to pick -1. And I'm going to put it in this. Because I know that 4 is positive. And if I multiply a positive by this, which is also positive, and I multiply it by this, which is also positive, I have a positive value times a positive value times a positive value, which is a positive value, and that means I'm increasing. And I recommend that you put that information literally on your number line. And then I'm going to do that same approach for a number outside of 0, which is 1. So 4 times 1 squared times 1 plus 3. 4 is positive, 1 squared is positive, 1 plus 3 is 4, so it's positive. And I end up with a bit of a problem, don't I? I don't alternate. I told you, hope I told you, that it doesn't always alternate. Sometimes in calculus you have these little trick points. So we have to figure out what's going on. We have to figure out how to decrease through this point down to the -3. Then we have to figure out how to increase and then stay increased, but something must happen here. And this is where you have to be aware of all the work you've done. And we found out that this was a point of inflection. And we know what the picture looks like. It's a positive degree 4, a positive degree 4 from advanced functions should look W-ish. So if I fit all this stuff together, I don't know why I keep doing that. If I fit all this stuff together, here's what happens. And I hope I can hold this straight. So you come down through here, so you're decreasing just like the test told you. And you decrease until you hit -3. And it should not be a abrupt point there. So let me fix that a little bit. Then we have to increase. So we have to increase up through this point here. And we have to make a point of inflection. So that's my best initial job. I'm going to try this once again, now that I know that I'm expecting a point of inflection. So I can spruce this up by making things a little more obvious. So I'm going to do this. I'm going to make this a little more obvious and then come back up through this point right here. And I think that is only incrementally better than my red version, which I'm going to get rid of. Now, if you are truly a terrible drawer, like it appears I am today, then what you want to do is you want to say things like, okay, tell us, I really wanted this to look like a point of inflection, and I really wanted this to look like a minimum, but it just wasn't working for me today. So you can label, and then you can like extra label. Okay, so that's how things fit together. There are very often trick points. There are also very often not trick points. It's sort of 50-50. It can do whatever it wants. So the last thing we're going to do is scary for some people, and that is we're going to sketch a graph, just a general graph, nothing specific, but with specific characteristics. So this says, sketch a graph of a function, meaning it must pass the vertical line test. Your first derivative has to be greater than 0, which means the first derivative is positive. And when the first derivative is positive, that means it's increasing. So this is saying it's increasing when x's are from -5 to 1, and then greater than 7, 7 to forever. Then it says, and f prime at x, the first derivative, is less than 0, meaning it's negative. That is a fancy way of saying it's decreasing, and it's decreasing when x is less than -5, meaning from -infinity up to -5, and it's also decreasing, oh, sneeze coming on. Excuse me. It's also decreasing from 1 to 7. Now, if you want to, and if you find it handy, you can take all this information and you can put it on a tiny little number line. So I know some important stuff happens at -5, at 1, and at 7. So that was me reading the important x values here. And it's the same important x values here. So it says that we are supposed to increase between -5 and 1. We're supposed to increase bigger than 7. We're supposed to decrease before -5. And we're supposed to decrease between 1 and 7. So that's what all this mumbo jumbo says. So now all we have to do is we have to take that stuff we did right here and add it to this picture. So again, I'm going to take a little tick and put -5 on the x. I'm going to put a little tick for 1. Scale doesn't matter as long as you're numerically accurate. And 7 out here. So I have to decrease, increase, decrease, increase. And it doesn't matter how you do this. So I'm going to pick blue for fun. So I have to decrease until -5. Then I have to increase until 1. I have to decrease until I'm in line with 7. and then I have to increase forever again. And that is one of a billion pictures you can have. What I will check is bad straight lines, that you are doing what you're supposed to be doing in those sections. So you're decreasing before -5, you are increasing between -5 and 1, you are decreasing between 1 and 7, and you are increasing after that. Now, as for the fine details, as in how high and how low you go, you can't say that. This is a general picture. So I only did my picture there because I couldn't have my little number line and this showing at the same time. It doesn't matter where you put it as long as you keep it lined up with the -5, 1, and 7. And another thing that's true, or untrue, depending on what you think, is I could decrease faster until -5. And then I don't know how I'm going to increase until 1, but there it's happening. And then I'm going to decrease till I get to 7, and then I'm going to increase again. So everybody's picture could be subtly different. All right, so that is your max min. We get to do this all again and more with the next topic. Curve sketching, not difficult, following steps, super annoying, lots of paper. So this, from your textbook, 164 number 4, 6, 7, 13, and 156 to 157 number 4 and 6. This may be adjusted for Quadmester system. Check the Google site.